LeetCode Problem 105, construct binary tree from preorder and inorder traversal. Alright, so this problem gives us two integer arrays, preorder and inorder. And it says here that preorder is basically starting from, it is traversing from the left to the right. So in this case, the preorder, we start from here, 3, go to the left, 9, and then go back, go to the right side, so 20, and then 15, go back to 7. So this is what our preorder is. You can see it's exactly the same. And then inorder is the Inorder Traversal, so which means that it is basically starting all the way. It is trying its best to go from the left up, right? So you start from 9, you go to 3, right? So 9, 3, and then you try to go to the left side. So 15, you go back at 20, and then you reach 7. Okay. So the way I built my binary tree using preorder and inorder is to use a recursive method, right? So it's a recursive method that uses the information of inorder. Like for this instance, if you see this tree here, basically what it means that all the numbers on the left will be at the left side of this node tree, and all the numbers on the right will be on the right side of this node tree, right? So with that in mind, let's walk through how the code works, and maybe you can further understand how what I mean by that. So we have our preorder and inorder. You can see here I am returning the preorder and inorder, right? And then my pre-start will be 0. My in start will be 0 as well. In end will be the size of the vector minus 1. So in this case it will be 4. Okay, pre-start is the starting index of preorder. In start is the starting index of in start. In end is the end index of inorder. Sorry, in start is the starting index of inorder as well. Okay, so once we come in, okay, in start is not more than in end, right? So we don't have to do anything. So we have another one called root while. So basically this is our value of the current node, right? So it's preorder and the pre-start. So pre-start is 0, preorder is 3, so root val is 3. Okay, then this for loop is basically trying to get the index of this root inside the inorder, right? So by iterating through, we can know that the inorder, or more like the root index, will be 1, right? 0, 1. Okay, and then we break out of the loop, and then we start constructing from the left. Okay, so I'm going to help visualize this. So right now we have constructed 3, so we are now building the left side. Okay, so the left side, let's do it like this. Okay, again, pre-order, inorder, okay, pre-start plus 1, right? Because we have already visited this. So pre-start plus 1, so now it is pre-start is now 1. In start, which is where we were, 0. In end will be the root index minus 1. Okay, so our root index was 1, which was where we found our node. Minus 1 will be here. So basically, if there were more numbers here, for example, so our in start will start from here actually, and it will end here, right? Because this tree was what we found. So we've split the list into two parts. Okay, but since there's only one number here, so this 9 will act as a list in itself. So in n will be 0 over here, and then we start the function. Okay, in start is not more than in n, so we don't have to do anything. Root val is equals to preorder pre-start. So preorder pre-start is 1, so the value is now 9. And I just create the root. Right, let's create the root. Then we iterate through to find where 9 is located in the in order. So root index is equals to, in this case, root index will equals to 0. Okay, then after that we construct the left node. Alright, so we construct the left node again. So we have constructed like this, 9. So now we're constructing the left node, and when we do that, in start, let's start out our values first. So pre-start plus 1, pre-start equals to 2, in start 0, and then root index minus 1. So now root index is 0, which means that we have reached the beginning of the list. So our root index will actually be -1, or in n, sorry. And when that happens, this will trigger and you return null. So we have created a null node here. Okay, so we exit left. So we now know null is left. Let's just write it down. Null. Now we are building the right side. And if you notice, the right side will basically mean from this 9 over here, right? But since there's no value here, it will also be null. So let's prove it. Let's try to prove it. Pre-start is equals to 2 plus root index, which is 0, minus in start, which is 0. So pre-start will still be 2. Our in start is going to be root index plus 1. So it's going to be 1. Our in n will stay the same. So in n stay 0. Okay, in this case, in start is still more than in n, so we can just return null. That means this will also be a null node. Okay, means it will be a null node. Okay, once we're done with that, we return the root from 9. Return the root from 9. Right now we're at 9. Right, you can see our root val is now 9. So we return the root. So our left practically is 9. Right, and this 9 will be pointing at 2 nulls, which I have deleted. Right, so left is null, right is null. Okay, but I won't make everything so messy, so I'm just gonna point to null, to 9. So 3, see our root val, which was 3, is now pointing to 9, which is correct. Okay, so let's move on to the right side. So preorder, inorder, pre-start plus 1. So pre-start is equals to 0 plus 1 plus root index minus in start, plus root index, which is 1, minus in start, which is 0. Okay, so this will give us 2. Our in start will be root index plus 1, which is 2. In n will stay the same, which is 4. Okay, once we're done with that, we begin the search. So this if statement will not trigger because in start is less than in n, which means we have a list. We have a list here, right? So in start 0, 1, 2, start from here, in and for. So we have a list here, which can be constructed into our subtree. Let's continue. So root val, preorder pre-start. So pre-start is 2, 0, 1, 2, preorder is 20. So right now our root val is 20. So we're constructing 20 now. 20. Okay, this for loop will find the index of 20 inside our in order, which in this case will be 0, 1, 2, 3. Okay, and then we construct our left node. Left node. Okay, so in our left node, pre-start, let's count again. Pre-start plus 1, pre-start is 2, 3, in start is 2, and then in end is root index minus 1. Okay, our root index was 3, minus 1 is 2. Okay, in start is not more than in end, they are the same. So we construct our root equals to pre-order or pre-start. Pre-start is 3, right? 0, 1, 2, 3, which is 15. Right, so we create a node. So here we have 15. We find the index, which is 0, 1, 2. And then we build the left. We build the left and the right. Okay, so you know, let's do it one more time now. So pre-start plus 1, 4, in start stays the same, and then in and now becomes root index, which is 2, which was 2, minus 1 is 1. Okay, and in this case, in start is more than in end, so we return null. So we know this is null. Okay, so this is now pointing to null. And basically it is the same thing for right. I won't be doing this repeatedly. So this will be right again. So left, right, null, null, both are nulls. Okay, and then we are done with left. So left returns the root. Our root is 15, so our left is 15. 15. And then we go do the same for our right. Okay, one last time. Preorder, in order, pre-start plus 1 equals to pre-start 2 plus 1. Okay, the reason why both of these are plus 1 is because we want to move on now, right? So this pre-order is basically what we are doing. We're iterating through each value here and constructing each node by order. Okay, so that's why there's a plus 1 here. Okay, 2 plus 1 plus root index, which is 3, minus in start, which is 2. Okay, so 3, 6 minus 2 is 4. So pre-start is 4. 0, 1, 2, 3, and 4. Right, so it's correct. Okay, pre-start is 4. In start is root index, is 3 plus 1. 3 get 4 is null. And then in end is in end, which is 4. Okay, and in this case, in start is the same as in end. So we can create the node. So pre-start 4, 0, 1, 2, 3, 4, which is 7. So we create our node 7. So here this is the 7. And then we calculate root index again, which is going to be 4 over here. And then we construct our left node, which is going to be null. And the right node, which is going to be null. Okay, so here we have both null and null. So we know our right node is now pointing at 7. And That's basically it. So when we return everything, we are going back to the root, which is 3. So 3 is pointing at left is 9, right, left is 9. On the right side is pointing at 20, and at 20 is pointing at 15 left, and right is pointing at 7 here. Okay, you can see we have created the binary tree, and then we return the root, which is this tree, which is this row of the binary tree. Okay, this is not a easy problem at all. It took me quite some time, but hopefully I've explained it well. That's all I have to show. Thanks.